And the goal says to solve the equations by factoring. If you can't factor it, you don't have to solve the problem. So you don't have to use the quadratic formula. It just says to solve by factoring. Quadratic formula is not expected. Then it also says to remember to factor out the GCF first. So when you are factoring and you're solving equations using factoring, what do you need to think about prior to doing any type of factoring? Isabella? Getting the x alone. So how would we try and get the x alone here? David? Right, so we need to subtract the 45 to take it to the other side so that it's set equal to 0. So now it's equal to 0. We do want to get x by itself. That is still the end goal. But in order to do that and to use factoring, it needs to be set equal to 0 first. So in order to factor, every single one of these problems has to equal 0. So now how do we factor this? Sarah?
Take out 5x.
So this is a GCF. They have a 5 in common, and they both have an x. So if we take out that 5x, Sarah, what do you get? Bless you. 4x minus 9. So GCF, they both have a 5 and an x in common. When you take that out, factoring, you write it in the front. Whatever's left after you pull out 5x goes in the middle, in the parentheses. And then you need to solve it. So we almost have x by itself. Essentially, you have an x on the outside of the parentheses, an x in the middle. How would you solve for those x's? What would you do, Sarah?
Well, for the ones inside the parentheses, you would just, you would get 9/4 because you would add 9 over
Yep.
and then divide by 4.
So solving for the parenthesis, setting it individually equal to 0. She said add the 9 over, divide by 4, you get 9/4. And then the other value,
You would divide by 5.
yeah, so if we set that equal to 0, divide by 5, and you get 0. So there are two answers here. Two answers because remember, it's a parabola. A parabola is a U. It has a left and a right. It has an axis of symmetry that cuts it in half. So these two x values mean that it's going to cross the x-axis twice. So make sure you have both of them because x equals 0 is part of the solution. And 9/4 is also part of the solution. Sam?
Did you do number 11?
I don't know if I like you today, Sam.
You like me today?
Yeah, I don't know.
Wow.
I look solid today.
No? You do have a pretty nice looking shirt on, so because of that, I think I'll help you out today. All right, so number 11, we have 50 minus 2x squared is equal to 0. Sam, what do you notice about the 50 and the 2x squared?
You can take 2 out of both of them.
You can take 2 out of both of them, so let's start by taking out a 2. Did anybody take anything else besides a 2 out?
The square part.
This-
The thingy. Yeah.
The square thingy?
You can like just square root it.
Okay, you
because-
can square
yeah.
root it. Isabella? Yeah, I would suggest taking a negative 2 out, but you're right, yes. If we take out a negative 2, Isabella, how does that change it by taking out a negative 2? It makes it x squared minus 25. So then Paige was saying you can take a square root thingy. So if you pull out a negative 2, because the x squared is negative. So if x squared is negative and you pull out a negative 2, then it makes it a positive x squared and now a negative 25. So Isabella, or I'm sorry, Paige, if we use the square root thingy,
You would do x plus 5, x minus 5.
right, you would have x plus 5, x minus 5. Both of those are perfect squares. And when you factor it, because you still need to factor it, it factors as x plus 5, x minus 5. So this is that difference of two squares pattern where you have a plus and a minus in order to get that x squared minus 25. Because that's how the middle term cancels when you have a plus and a minus. So then to solve it, there should be two answers. The x plus 5 gives you a negative 5 as a solution. The x minus 5 gives you a positive 5 as a solution. What about this number here, the negative 2?
Negative 2 equals 0.
Yeah, so negative 2 equals 0. Negative 2 doesn't equal 0.
Because there's no x.
There's no x with it. So if there's not an x with it, it's not part of your solution. That was just the GCF that you pulled out. And it was just a number that was a GCF. It didn't have a variable with it. So negative 2 cannot equal 0, not even on a Wednesday. Never does it equal 0. And it doesn't really have anything to do with the problem. You could think about it as like dividing by negative 2. If you wanted to really get rid of it, you could divide by negative 2 on the left, you could divide by negative 2 on the right, and then it's gone. But it does not equal 0. It's not a solution, it doesn't have an x.
For these factoring problems, we're all like making them equal to 0. There's none of those that are like, well, you know, the one way to factor where there's.
Oh, that would be the completing the square.
Yeah, are
Yeah.
we doing that?
No.
Okay.
So set them all equal to 0
I
factor.
wasn't good at that.
So no completing the square there. Sarah.
Can we do number 17?
It was like where it didn't equal 0 when we had to like divide by 2 times something.
Get it equal to 0.
All right, so the other one that we have up here, bottom of the page, number 17, is 3x cubed plus 9x equals 6x squared. So knowing that I said all of these problems need to be set equal to 0, we're going to have to set this one equal to 0. What does it look like if you set this one equal to 0? How would you arrange your numbers, Virginia?
3x cubed minus 6x squared plus 9x equals 0.
Right. So you're going to subtract the 6x squared to the other side. That term should go in the middle. And then we have 3x cubed minus 6x squared plus 9x equals 0. So then the second step would be to ask yourself if there's a GCF. Is there a GCF involved in any of these numbers up here? A 3 and an x. So they're all divisible by 3. They also have an x. When you take out a 3x, what do you have left?
X squared minus 6x.
Oop, forgot to take out a 3, I think. So x squared minus 2x, and then plus 3. There you go. All right, so then the third step would try to be AC grouping. Does that work for this problem? So that would be my third step after you take out a GCF. Well, we set it equal to 0. We took out a GCF, and now we need to try and factor it. So we have a positive 3 in the back. We're trying to make a negative 2. The only two factors of 3 are 1 times 3. Ethan, why doesn't it work? You're shaking your head.
Because to make it negative 2, it would have to be negative 1.
How about
No,
a
it
negative
would have to be negative
3? Yeah. Okay, so that makes negative 2, but what's wrong?
It doesn't equal positive.
It doesn't equal positive 3. So this one here can't be factored any further. Like, yes, you can pull out a 3x, but this middle term here, those 3 terms in the parentheses, they can't break down or factor. Aaron,
We use the quadratic formula.
if you'd like to, you could, yes.
You have to.
You don't have to because it just says to solve by factoring. So if you would like to use the quadratic formula, awesome. But you still need to solve for the one part that we pulled out. So don't forget about that one little piece there. We did factor out the 3x, so we know for sure that x is equal to 0. You can use the quadratic formula if you would like to find the others, but it's not necessary.
15.
Yeah, I'm sorry, I'm done.
What? Oh.
Sorry.
What?
So if you have other questions, you'll have to see me at another time. I have 20 minutes and I have to get definitely started on some of the notes. So you got 3 questions, which is pretty nice. I mean, it's being graded, so sorry, Isaac, it's not that I don't like
Maddie
them.
helped me.
Okay.
Are you collecting the ones that are done?
Yeah, if you have it done and you want to pass it forward, you can please do that. I'll take it from you. Your quizzes are graded, however, I still have like 2 classes to go yet. So I would say by tomorrow morning, it'll be on Power School. But there's about 6 or 7 that need to make it up. So hopefully by Friday I can give them back to you.
Yeah.
In your notes, if you'll turn to page 15.
I went home yesterday and passed out and I went to bed at like, I woke up and that was the best thing that's ever
I'm
happened.
gonna join you in this conversation. I went to bed at 1:30.
Wow. Ryan, you posted.
Dude, I bet I'll tell you. The other day I went to bed at 2:46.
Oh yeah.
No.
2:46. That's very specific.
Yeah.
Why are you, like, you're always up, and then you're like, I'm so tired, and then I never do my homework, but I'm up until 2 in the morning.
I do my homework. Oh, no.
Now what are you doing?
Actually, I don't know. What am I?
Is it you good? Like you're ready? mad because I wasn't going to answer her questions, and she's like,
Yeah,
I'm
I'm just
not
defying
gonna
you.
not
I'm being
say.
rebellious.
I got it.
Miss Kate, you've been very colorful the past couple of years.
Yeah, well, I mean, it's a little warm, so I feel like it's so much blah throughout the winter.
Oh,
Yeah, it's warm blah. Like the rest of the week is going to be blah.
rainy and gross.
Yeah.
And I have to be outside.
Yeah, that's fine.
We could have been in the gym, but no, we're gonna have to go outside. We're gonna get sick.
Maybe it'll be not so rainy after school.
I know.
I don't know.
So I was just sick. I know I'm gonna get sick. I'm
Alright,
hungry.
so we are going to start the second part of the chapter today, which deals with a new function. So the new function in the first part was the exponential function where x was the variable as the exponent. And in order to work with those exponents and to solve when x is an exponent, mathematicians had to be like, alright, we need something else because we don't have calculators. So we need some other way to solve when we don't know the exponent, because we do know that 2 squared is 4, and we know that 2 cubed is 8, but the number in the middle, we don't know. We don't know what power of 2 would give us 6. So, of course, math people being math people, they don't like when there's not an answer to something, which is why I like math, because it's right or wrong. It's not like English and those papers that you'll have to write. They're very subjective. Yeah. Not in math, it's right or wrong. So when the problem came up where, well, what if I don't know what an exponent is, what the exponent could be, and it's supposed to equal 6, how can we figure that out? They didn't have calculators. What we've been doing to solve these problems is using the calculator, but of course, we're going to try and not use that calculator in all instances here. So a logarithm was created in order to solve this type of problem. So that's why another function was made. So we have these exponents. We can't find this x as an exponent without a different function to help us solve it. So a logarithm was created so that we can solve for those types of problems. So just kind of thinking back to the last 3 sections. They were all exponential form. Usually we said it was y equals ab to the x because a was your initial value. So right now I'm just going to say a would be 1 if I wanted to put a little 1 there. But we're just going to work with the equation y equals b to the x. So b is your base. That's what we defined it as. That was the base. If that base was bigger than 1, it grew. If the base was less than 1, the graph decayed. So thinking of now a logarithm, it says let b and y be positive numbers and b is not equal to 1. Because usually we solve for x. When you're trying to solve for an equation, it's always the x you want to solve for. So that's why they're defining it with the b and the y. So b is the base. It can't be 1 because if it was 1, 1 to any number is just a line. 1 cubed is 1. 1 to the 5th is still 1. So I just have a constant line. It wouldn't be an exponential equation. The logarithm of y with a base b is defined by the following. Y base or log base b of y is equal to x if and only if, conditional statement from geometry, b to the x is equal to y, which would be our exponential form. So the exponential form that we've used for 3 sections in the first half of the chapter was that y equals b to the x. So b is still the base, and it is like a little subscript, so you write it lower. The y would be my dependent variable, and the x is what we're trying to find or what we're trying to solve for. So you would read this expression, you would say log base b of y. So if I had log base 5, 3, come on, Apple TV, there we go. I would read that as log base 5 of 3. So that's how I would read that. So you kind of have to get used to like actually reading it when you're looking at the problem. But the little 5 should be underneath the log, like or lower than the word log. The 3 should be in line with it. So the 3 and the word log should be kind of in the same line. So the base literally is like a subscript. It's sitting lower, just like an exponent is sitting higher. So there's 2 forms. our goal to first start off is to just try and convert from one form to the other, just to get you used to seeing how they kind of go together, how they work together. But this is kind of like multiplication and division. Like multiplication, division, they're opposites of each other. Same thing with logs and exponents, they're opposites of each other. We use one to solve for the other. So if I'm trying to solve 7 times x equals 35, I divide to get x equals 5. So it's the same thing here, like they're the same kind of functions that work similarly. You need one in order to solve for the other. So exponential form, y equals b to the x. That's how we write an exponent, y equals b to the x. The new logarithmic form, log base b. So this b is a base because it's attached to an exponent. It's also a base when it's with the log. That part doesn't change. If it's a base, it remains the base. And then the y is with the log, the x is on the other side because that's what we're trying to find. If I'm finding x, I'm solving for x, so it's on the other side of the equation. Yes?
Is log like one of those special numbers like b or pi?
It's not an actual number, but it's a function that creates a number. So it's not like 2.718. It doesn't always have the same number. And that's because this number here, that changes what the value of the log would be. Good question. Other questions? So the first part of the problems that we're going to do just want us to convert from one form to the other. I'm going to write these above again. So log base b, y equals x, or y equals b to the x. So the goal is just to get you used to converting. You have a log, you want to convert it to an exponent. Or you have an exponent, you want to convert it to a log. Because that's how we're going to be solving for these. So the first one says log base 2 of 32 is equal to 5. And we want to write it as an exponent. So somebody try and convert it from the log form to an exponent. Page.
32 equals 2 to the 5th.
So 32 is equal to 2 to the 5th. So 32 is the y, 5 is the x, the little 2 is my b. Log base b of y is equal to 32. When you write it as an exponent, it should make sense. So Paige, does 2 to the 5th equal 32? Yes. If you have it written 2 to the 5th equals 32, if you've got it the other way, that's fine. It means the same thing. You're just writing it in the opposite form or the opposite direction. But it should make sense when you see it as an exponent. So the next one, for letter B, we have 1,000 is equal to 10 cubed. Well, 10 cubed is 1,000, so that's true. We want to write it as a log. So how could I change that and write it in logarithmic form?
Log base 10, and then it would be 1,000. That would be 3.
So y is the 1,000, the x is the 3, the 10 is my base. So 10 is the base of the log, it's the base of the exponent as well. Letter C says log base 7 of 1 equals 0. Isa, what do you think? Can you try it?
Okay, so 0 equals 7 to the 1.
Good. Does 7 to the first equal 0? Yes, anything to the first, or anything to the, no wait,
Wait, no.
that doesn't make sense.
No, not at all.
7 to the first is not equal to 0.
1 equals 7 to the 0.
There we go. 1 is equal to 7 to the 0.
Oh, I wrote it down.
So 7 to the 0 does equal 1. Anything to the 0 power is equal to 1. So the base is 7 with the power of 0, it should equal 1. Letter D, we have 1/2 equals 2 to the negative 1. Does 2 to the negative 1 equal 1/2? What happens when you have a negative exponent?
Oh, good. Flip it.
Flip it.
Yeah, you flip it. You put it under 1. Sam, do you think you could write it
Yeah,
as a
it's
log?
gonna be log base 2 log base 2 hold on. Sorry, log base 2 of 1/2
Good.
equals negative 1.
Equals negative 1. Good. And then the last one here, log base 13 of 13 equals 1. Mason, what do you think?
13 equals 13.
So 13 equals 13. We'll add that little first there just to show the true conversion. 13 to the first does equal 13. Questions? Okay, so the next group of problems ask us to evaluate. We're going to try and use this information to help us. We're also trying to not rely on that calculator. Only when absolutely necessary will we kind of convert to the calculator. So this says to evaluate each of the following logarithms. Evaluate is another way of saying solve. It's another way of simplify, saying simplify, breaking down. We have log base 3 of 81. So that we can get it in the log form, so log base b of y equals x, I'm just going to put all these equal to x. That way you know it's kind of like an equation that we're trying to solve for. Because we really are trying to find the x. We're trying to find the number on the other side. And then just a reminder, that's the other form as well. So our goal is to evaluate. No, you're not going to just plug this in the calculator and out pops a magic number. Doesn't quite work like that. How do you think you could try and use what we just did to get us to kind of work through and evaluate? Virginia?
Could you switch it to exponential form?
We can switch it to exponential form. So that's why the two exist and they kind of work together. So if you can't do something when it's written one way, then try and rewrite it and maybe you can work through the problem. So Virginia, how would you switch to exponential form?
If the 81 equals 3 to the x.
So the y, here's your base, and then it is x over there. So the base is 3. 3 to what power is equal to 81? So if you still have that common power sheet, perfect to use. Otherwise, just kind of think about it. Aaron, what do you think? It is 4. So 3 times 3 is 9. Another 3 times 3 makes another 9. And 9 times 9 is 81. So 3 to the 4th is equal to 81. So now I have a true statement. So this x is equal to 4. But we've solved it using exponents because that's how we know how to work with exponents. We can solve those. So looking at the next one, kind of working through it the same way. We have 0.25 equals 4 to the x. How else can we write 0.25? 1/4, yeah.
Oh, it's negative 1.
Yeah, nice. So 4 to what number makes it 1/4? Well, a negative exponent is how you get that fraction. So 4 to the negative 1 is equal to 1/4. Looking at the next one here, again, trying to rewrite it. So 256 is equal to 1/4 to the x. So think about it. Don't just quickly revert to that calculator. Use your brain a little bit and some logic. If letter B had a negative exponent to get it into a fraction, if we currently have a fraction and I wanted a whole number, what's the exponent going to have to be? A negative. So this is going to be negative. Because if you have a fraction and you want to make it a whole number, in order to get that number to flip, you have to have a negative exponent. And Sarah said it would be negative 4. So 256 is equal to 1/4 to the negative 4 because that flips it around. So that's really 4 to the 4 is equal to 256, which is true. The last one here, again trying to rewrite it. So we have 7 is equal to, the base is 49 to the x power. Kate, what do you think?
Would it be 1/2?
Why 1/2?
Because 7 is the square root of 49.
So 49 to the 1/2 power. When you have something to the 1/2 power, that's really the square root. And that is equal to 7. So, this requires you to remember stuff about exponents. You have to remember negative exponents, flip it. Fractional exponents is really a square root. Questions? So we're going to do one other thing at the top of the next page. It's just kind of actually trying to show you where to use the calculator. But are there questions with these problems? Because the majority of your homework will look like this page. So then if you flip it to the other side, there are 2 logs that are commonly used and that are also stored in the calculator. So the calculator has 2 logs stored in its memory. The one is actually called the common log, and the common log is the log with the base of 10. So a common log, which is the one in the calculator. So both of these are in the calculator. Is the log with a base of 10. However, you will see only the log with a number. You're not going to see that base 10 written. So if it's not there, it's assumed to be there. And I know in math we usually try not to assume. But if you only see log 3 without any base here, it's assumed that that base is 10. So Isabella, you were asking about, does the value always change? The calculator has one log in the calculator with a base of 10, and that value will never change because it's always a base of 10. The other log is called the natural logarithm, and we talked about the natural base. Does anybody remember what the natural base was from last week? Page? E. So the natural base is the log with a base E. So there's two logs that are commonly used stored in the calculator. One has a base of 10, the other one has the E with it. And we actually write that as ln with the x. So you will not see log base E. Instead, you'll see the natural log of x. Sandy.
How come logs like the 10 is the common one if we haven't seen that once?
Because it wasn't on the other page, is that what you mean?
Yeah.
I mean, I could have had some on the other page, but I was just trying to get you to use other numbers. But because like 10 is a fairly the number 10 is a base number, it kind of is easily associated with other values.
Is there a way to make it a number that's not 10?
Not by using the button in the calculator.
You have to go in the math.
Yes. Yep. So if you look at your calculator, there's two problems at the bottom, and we're just going to finish up with these two problems. But just look at your calculator. So the first one says log 8. So last week when we were looking at the calculator and looking at E, there are two buttons that you'll be using. The log, L-O-G, above it says 10 to the x. So my base is 10 to whatever exponent, so that tells you that the log has a base of 10. The one underneath it says ln, and that's where above it was the e. So we've used both, well, we actually used the e one, but we could have used any value with the 10 to the x as well. But these are common functions that you would use outside real world kind of thing. So the first one says log 8, so literally you're just plugging in log 8. You don't have to do anything else with it, just hit enter and you get 0.903. So for letter A, the log of 8 is 0.903. That has a common base. So if that base changes, you can't press that button if it had a different base. The second one was the natural log of 0.3?
Yeah.
Yes? So I use the natural log button, ln, put in a 0.3, hit enter, and you get negative 1.204. Isabella.
So when you do log 8, you actually do 8 equals 10 to the x.
Yes, that is exactly what you're doing.
Yeah. So what if you want to solve for something that's not 10?
Then we would do what we did on the other page.
Oh,
So you're still rewriting it.
Alright.
Anybody interested in doing 13 and 15? They go together because they're pretty easy. And 75. So Sam, 75, Grace, 13, 15?
Wait, I'm doing 75?
75.
Do it.
Oh yeah, how it goes.
Why did you do it yesterday?
Because you're walking.
Have an awesome day.